So we're gonna do problem 16 and says find the area of a rhombus whose diagonals have like 4 and 9. Well, how do we do this? Well, obviously we know that the formula for an area of a rhombus is diagonal 1. So this is diagonal 1. This length right over here. And this length is diagonal 2. So basically the area is diagonal 1 times diagonal 2 divided by 2. So basically it's 4 times 9 divided by 2, which is obviously 18. Now, this one, we know the area of a circle. Area of a circle is obviously pi r squared. So basically all we have to do right now is find the 2 pi r. So hit 2 pi r is equal to 64 pi. There's a r equals to 2. The whole point was to find the radius because the radius is really important. And then from there, you get that 32 squared times pi. We just need to find the radius. The radius is 32. I thought I was finding the area. Sorry about that. So I'll give you a moment to digest, and we'll move on. Part 18. If the circumference of a circle is 8 pi, what is the area? So 8 pi is equal to 2 pi r. We're going to find the radius. Gives us radius is equal to 4. And then from there, it's pretty easy. So we know area of a circle is equal to 2 pi, pi r squared. So plug in r equals 4. 4 squared is 16 pi, gives us A as an answer. Now to 19. In the figure, the center of the circle is O, and AB is tangent to the circle at point B. What is the area of the shaded region? So, you might ask, what is the shaded region? I don't know what happened. So I'll tell you the shaded region is, what is it? It's about, let me see what it is. Oh, here. That's the shaded region. I think I shaded in black hand. So I shaded region in this one. Sorry if you guys couldn't find the shaded region. But anyways, so basically from there, we just need to find the area of this sector and the area of this triangle. This triangle, gotta find the area of. And then from there, we can easily see the answer to this problem because we just need to find the area of this triangle. We covered this in the first lesson. What was the first lesson? The first lesson was, we talked about 30, 60, 90 triangle. What were these triangles? Well, 30, 60, 90 triangles, the area, this is basically saying angles were 30, 60, 90. This is, and say this is, length of this is x, and this is 1/2 of x, and root 3 over 2x. Basically, it comes from an equilateral triangle. And from there, you can literally find the area, and I'm not going to go in much detail on that, but the area of this triangle, the highlighted in red, is basically 72 squared root of 3, And then we can realize it's either C or D. And then from there, the area of the sector. We have to subtract this area of the sector, which turns out to be 12 times 12 divided by 6 pi. Why? How did I come to it? You just find the area of the entire circle and find the degree ratio. 60 divided by 360. Multiply that by the degree ratio, simplifies to 1/6. So 12 times 12 divided by 6 is equal to 24. So basically, area sector is 24 pi, and the shaded region is D. And then 20, the shaded region is this place. Basically, you gotta find the area of the smaller circle, a full circle, which is right over here. This smaller full circle, and subtract that from the area of this half circle, a bigger one. From there, the area of the half circle is 8 pi, which is basically 1/2 of the full circle, and we know the radius is 4. And the area of the small circle is basically 2, which is basically 4 pi, because basically 2 times pi. And from there, it's pretty obvious where to find. Oops. I mean, this is the shaded region. Sorry, it wasn't double. Sorry about that. But basically, the same idea holds. Just find this area of the quarter circle, subtract it from half of this circle, which is pretty simple. And I think you can get the answer as 2 pi. Okay, because the area of this quarter circle is 4 pi, area of the half circle is 2 pi, subtract and get 2 pi. Alright? So today's lesson is going to be applying our area knowledge and perimeter knowledge to solve trickier problems. Well, somewhat. And this one, well, we can just give it a go and we'll see. And there's a smiling face. Okay. So, for example 25. So, in the rectangle shown, the radius of each circle is 6. What is the area of the shaded region? So here, I'm going to show you the shaded region is right over here. You go, that's the shaded region. It's just the region of the area of the rectangle subtracted from the region areas of the circles. Now, guys, let you guys get a try on this problem and see what you guys get. And please tell me in the chat. Probably for 1 and 2 minutes, okay? Okay, so one of you guys got it right out of all the answers. I got it right now. And the answer was, I'm not telling you right now. Okay, so first off, how do we solve this problem? Well, first off, notice that this length right over here is 8. So that's nice. And we'll find the area of the rectangle. And we subtract it from these circles. So, an insight from a person called No Name before, this person's insight was to like try to configure it into a bigger circle. Like for example, these are quarter circles. We can put them together, like add a piece over here, add a piece over there, add a piece over there. That configures it into a full circle, which we know is pi r squared, instead of calculating each one on the same one. And this one, we can actually use this. Since there's one over here, it's going to see over there, 3 quarter circles, and then 4 quarter circles. And 4 quarter circles add up to a full circle. And then from there, we can say the radius of that full circle has 6, right? And so the area is going to be 6 squared times pi, or 36 pi. That's the area of the not shaded region. And we want to find the total area and subtract it to find the shaded region. So we're gonna first find the total area and subtract the pieces that are not in the shaded region. So in this case, the side length of this is 8. Side length of this is 6. 8 plus 6 plus 6 is equal to 20. So this area length right over here, 20. Now, this length is 6 and also 6. So this length is 12. Why? Because it's a radius. A circle definition is that the center is the same distance from each of the points on the circle. And from there, area is 12 times 20 is equal to 240. That's the total area. We want the shaded region. So we subtract 36 pi. And that gives us E. Over here. On to the next one. By the way, do you guys have any questions? Okay, there seems like no questions. So, example 26. It arcs. Okay, so where's 240? 240 came out from the area of this entire shaded region. I shaded in green. The entire rectangle came from that. Okay? Okay, so let's move on to example 26. In square ABCD, AB equals 1. BD and CAC are arcs of radius 1. Two of the shaded areas are the same. Find the difference between difference of the unshaded areas. So basically, well, you guys try to solve it. I'll give you guys 1 to 2 minutes and we'll talk about it. Okay? Feel free to ask questions. Ask questions by raising your hand or typing in chat. so let's just get started now. So answer was A. So why was it A? Honestly, it's pretty tricky. Basically, the answer is A. Why is that though? So basically, S is these two areas are the same. You know this. So we might as well leverage the fact that we know that it's an arc of with radius is 1. Normally when you see this, technically means that arc with radius 1 is basically a circle, a part of a circle with radius 1 or radius r. It's like, for example, we call this an arc with radius 1 because it's basically part of a circle with radius something. So in this case, we know this is 1 and that's 1. It's square. So from there, we can write S1 in terms of S. So S1 plus S is equal to pi over 4. Remember, the area of this over here, area right over here, is pi fourths. So area, because it's pi r squared on 4. It's a quarter of a circle. Now, so basically where the 4 came from, the 4 came from the part being a quarter circle. So it's like this. There, it's a quarter circle. It's part of the quarter circle, but it's not right. So in this case, you know, the area is going to be pi over 4. And this area is going to be this S1 is going to be pi fourths minus S. If we isolate it by one side. So S1 is pi fourths minus S. So now, what about S2? Pi fourths, basically it's pi 1 minus pi fourths. The area of this entire square is 1 basically. And we subtract S. It's that simple. Why? Because this shaded region is S, and the area of this shaded region is 1 minus pi fourths at S. So obviously, this is going to be 1 minus pi fourths minus S. So then we can subtract basically these two together. So difference is going to be pi fourths S minus 1 minus pi fourths. It's going to be, we add, basically going to give us the plus S. It cancels out. Add this together. We subtract 1. Gives us pi halves minus 1 as our answer. Okay. So now let's just move on to 27. I'll still give you guys about 1 to 2 minutes. Feel free to ask questions. And tell me your answers in the chat. I don't know if you guys can see the figure in this example. So here we go. We want to show you the figure. I'm not good at drawing, so I'm gonna try my best. This is the half circle, right? This is AD. D, and this is D. In there. Trisect means to split it into three parts of equal length.
Can you do the shaded area?
This. So
It says find a shaded area, but can you shade it?
sure.
Well, you need to find the shaded area, not to draw it.
I know. So I'll show
Okay.
it's right over here. Yeah, I'm pretty sure that's the shaded area. Yeah, that's right. Yeah, let's just get started then. So basically, the answer was actually 8. The key thing was to notice that, oops, this place is basically equal to this area, equal to that area. Let's make the diagram a bit more better. So that since we know it's trisect a figure, so this length I shaded in blue is the same as this length I shaded in green, and this length I shaded in black. Or I'll shade it in different color then. I'll shade it in pink. There's the color. Look there. You can draw the base, imaginary base. You can extend and make a line. This over here has the same height. Notice it's the same height and the same base. So they'll have the same area. So this arc, this sector right over here, shaded in green, so the same area of the sector are shaded in yellow. And since that sector covers only half, 1/3 of half the circle, and and the area of the half circle is 9 pi, it's 1/3 times 9 pi or 3 pi. So that's the answer, 3 pi. Example 28. Semicircles of radius 2 and 3 are externally tangent or are circumscribed by a third semicircle as shown in the figure. Find the area of the shaded region. The shaded region in this example, we shaded blue, is this figure. I think they call this the arbellos or ARBELOS, arbellos. Something like this figure. So I'm gonna let you guys have a go and we'll get started with the question, okay? I'll let you guys have a go, okay? So tell me the answers through the chat, okay? So what externally tangent means? Externally tangent means the tangent point. So before we talked about what tangent is, there's literally two types of tangencies. They can either be tangent, you can just call it tangent, or in circles, this line, there's two circles, if there's this line that passes through it, and then it intersects at one point both, and imagine if there's a rectangle over here, if it goes inside the rectangle, it's internally tangent. And externally tangent is where that there's a line and they both intersect it, but that just goes just on the rectangle. Or just and so basically it's just on the rectangle. So for example, you can just draw this random shape. Call this a rectangle, our rectangle. Doesn't really matter if it looks like a rectangle or not. Basically you can just say it's this line where I drew over here. It's externally tangent to the line is externally tangent to both of the circles. And vice versa, you can replace the line with the circle. We can do it with the externally tangent case, but not the internally tangent case. But it could be internally tangent, yeah. Okay, so now let's look at a scenario with this question. So how would you solve this problem? 28. So semicircles of radius 2 and 3 are externally tangent and circumscribed by a third semicircle and as shown below. Find the area of the shaded region. Well, there's two methods of approach. One, completing the circle. Two, straight out bash, just straight out calculate all of this. So the answer was C, in fact. So if I first looked at this problem, I would first say, well, let's just find the area of the semicircle. What could go wrong? Say, so the area of this semicircle is 9 pi on 2, because this area of the full circle is 9 pi. And the half circle is basically 9 pi over 2. Area of this circle, I think in blue, is basically 2 pi. And that's basically because the area of the full circle is 4 pi, the area is 2 pi. So basically, half of the area is 2 pi. So basically add them up and you get uh 11 pi, right? Let me see. Whoopsies. Oh wait, that's right. It gives us 11 pi over 2. Just fact checking to see I did not make a mistake. It's always good to do that. And then the area of the entire thing is going to be 25 pi over 2 because that's a half circle and this is 3, this is 2. Add that all up, you get 10 as total. 10 divided by 2 is 5 means the radius is 5. 5 squared is 25. And the area of the half circle of the entire figure is 25 over 2 pi. Subtract, get 12 pi. Which you can do easily in your head is 6 pi. Or you can write it down on paper and calculate it. It gives our answer 6 pi. Another way we could have done this is actually to make this bigger. Complete this. And then, for following the similar approach, we just find the area of the bigger circle, the biggest circle actually, this circle, and subtract the basically subtract this region, add the areas of this region, right over here, and then subtract it from the entire region over here that envelopes everything, and then divide by 2 because there's 2 of these, one over here, and then one over here. It still gives you 6 pi. That's good enough. So now let's go on the problems. So those were the examples. Now let's go on the problem. Now I'll give you guys time to solve it and try it out. So without further ado, tell me the answers in the chat, or you may feel free to ask questions. Okay? So try to solve this problem. Okay, so let's just get started with this question then. So here we go. First off, how would we solve this problem? So notice that they say that the sides are equal because they're saucer. That's a key thing to know. And then legs of length 4 centimeters, meaning that this is 4 centimeters in total, right over here. Three circles under A and B C are drawn in the region inside of the circle triangle is shown. How many centimeters are in the shaded region? So now the midpoints are D and E, so we know this is 2, and that's 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 2. So, since, and you know why that's why AD and FC are 2? It's because it's a circle, as we talked before, all constant, the entire center to the edge of the circle are constant length. From there, we can probably quite easily find the area. Notice this. But first of all, you guys might not know where to start. So, first of all, notice that the angles add up to 180. And they're also part of the same circle. Why is that important? Because it means that we can place them right over here and make them the same circle, half circle. And guess what that half circle has? A radius of 2. So from there, we can quickly see that the area of that triangle, the area that has that circle is 2 pi. So the half circle is 2 pi. Notice they say it's a right isosceles, so it's a right triangle now. So basically the area of that is 4 times 4 divided by 2, or 8. So 8 minus 2 pi, or C is our answer. Move on to 22. The square is constructed on diameter AC, such that the area of the square equal to the area of the circle. What percent of AC is BC? I'm gonna let you guys have a go on this. So they're basically asking what is AC divided by BC. What is AC divided by BC? That's just what they want to find. So I'll let you guys have a try on this, and then you guys can get the answer, and I'll let you guys have a try. Okay? Feel free to ask questions. Tell me to chat. This was the question.
Is there like a model?
Oh, there wasn't a model actually. You were just supposed to draw it for yourself. But I could draw a model for you guys. You want it? So I'm gonna draw a model then. Okay, so Let me hold up and let me draw the model. Okay. So this was the square, right? And the circle is over here, and that's on the radius. That's basically it. And then they didn't place B at anywhere. So I'm gonna put B over here. And there was supposed to be an answer choice. So I'll give you guys some answer choices, alright? So basically the answer choices were A equals square root of pi over 2. B is equal to pi over 2. 3/4. D 3 pi over 4. E 2 minus pi halves. Those were the answer choices. I'll let you guys have a go on this question. Try to find something else. Get the answer from there, okay? So what's your question?
Do we make our own numbers or use the numbers you wrote down?
Numbers I wrote down as the answer choices. Because those are the
Uh, so it's like so A is the square root of A is so the so you mean like B is like
straight up pi divided by 2, okay? It doesn't look clear, but I hope you guys can read the back of your head. It's square pi divided by 2, okay? Also, a hint is it's not C, D, or E. It's one of A or one of B. So basically, the answer was square root of pi divided by 2 or the A. Okay, so why is that? Why is it A? So first of all, we're gonna let this AB be M. So this is 2R minus M. Because the AC is 2R. And then from there, we know that we multiply and we find the area is basically 2R minus M squared is equal to M squared R squared pi. And then there you get some, and then you can take the square root of both sides. Get square R squared so pi is equal to 2R minus M, or M is equal to 2R minus square root of pi by R times R. And then so from there, you find what BC divided by AC is. Oops, sorry, it was supposed to be BC on AC. I'm sorry if y'all got confused. My fault. And so basically from there, you get this is equal to 2R minus M. 2 divided by 2R, or 1 minus M divided by 2R, or 2R minus square root of pi R divided by 2R, and then expanding it from there gives us square root of pi over 2. Just take the divide, this gives us 1. 1 minus 1 is 0. And negative of negative pi squared of R. Positive, so it's going to be positive pi divided by 2, or this answer. That's basically A. So now let's start 23. You guys can give it a try. And I'll wait for you guys to get an answer. Please send the chat and ask me if you have any questions, alright? I'm going to have a go.
Where is the shaded area? Is it the middle or it's just one of this quarter pie? Uh,
So basically, the shaded area is the center, actually. So I'm going to draw it off. The center. This part. Okay? Is this good? So basically what you can do is find the areas of the three sectors and subtract it from the area of the equilateral triangle. So let's go on with it. So basically, what we do is basically all you do is find the area of the equilateral triangle, which was area the side length was 2. So basically from there, 2 squared squared to 3 divided by 4. Use the square root of 3 as the area of the equilateral triangle. And then from there, you can see it's either D or E. No need to guess right now. We know D is the midpoint, so this length is 1. So, and then from there, it's 1. It's there. And then from there, since the angles are 60 degrees and they add up to 180, there's a half a circle of with radius of 1. You find the area of a circle with radius 1, and that's half of it. It gives us minus pi divided by 2. It gives us E as our answer right over here. And that's not our answer. That's not our answer. Hope you guys can understand this. Feel free to ask questions. So now let's go to 24. And then we'll find the area of the shaded region. The shaded region, I think, was this thing. Right here. I'd let you guys have a try on this.
So, are you sure it's the middle part or the other parts of the square? And can you please zoom out, please? Yeah, thank you.
So basically, it's basically yeah, it's basically the middle part. Yeah, I'm right. It's the middle part. So no need to worry. So basically, find the area in the middle part. One hint is think about the pieces over here and there. Try and see if you can place it together. So let's go have a go on it and tell me the answers to chat. So I'm gonna start this. So the answer was A, actually. So why was the answer A? It's because realize that we can put this together with this, and then we can make a smaller square, half on the side, right? And half on the other side. So basically, from there, we make two of them. There's one pair, there's two pairs. 2 times 36, because we split it in half, is 6. Just 72. I'm subtracting from the total area, which was 12. Times 12, or 144, gives us a grand total of 72. So, for uh, for what we use basically today is make sure you understand that how to bisect a figure and split it in half. Like, for example, in this figure, we can rearrange the pieces that we don't like. Really don't know how the areas off. And then from there, we can quickly find the areas. For example, what over here, our lesson statement was find our area knowledge and perimeter problem knowledge to solve trickier problems. So basically, that's what we've been applying. So we've been applying a rearrangement, some substitutions, and some smart thinking. So that's it for today. It's 8 o'clock. Have a good night and have a good weekend. And I'll see you next week. Bye.